So sometimes they can ask you this question: distinguish between rate of reaction and a specific rate constant for the reaction. How will you define it? Or who has any idea the difference between the rate of reaction and the specific rate constant for the reaction? The rate of a chemical reaction and the specific rate constant for the reaction. Can you tell me? Hello? Hello?
Hello.
Oh, mine means more. Uh, talk to me, Ruben. So when talk of that, I hope you can all hear me. If you can't hear me, just let me know. When you say the rate of reaction, then basically we are saying that the amount of reactant consumed per unit time. That I've already explained the other time. And normally it is given by, for instance, if you have A plus B plus, will give you C, then the rate of reaction will normally is subjective to the molecule in question. When I say subjective to the molecule, then we are trying to say that maybe a question says that give the rate of reaction of molecule A. Then now you are going to say R is equal to D negative. If it is the reactant, then you are talking about the negatives because there's a disappearance. Now, if it is the product, you are talking about the positive. So that one be D. That will be something like this. So, for instance, if you are given the rate of reaction, if you are given something like C plus D is equal to maybe F, the rate of reaction you are seeing that is the amount of reactant consumed or the amount of product produced. And so, if you want to use any of them, you can simply define the rate of reaction or mathematically by saying that the rate R of A is given by negative D, the concentration of C all over the T. This is the rate of reaction. Now, however, when we talk about the rate, the specific rate constant, we are talking about the specific rate constant is the proportionality constant in the rate law at a given temperature. In the rate law at a given temperature. In the rate law at a given temperature. So that one is normally the constant in the rate law. That one is the constant in the rate law. So that one, I told you the other day, if you are given a rate law like R is equal to, maybe writing the rate law of this will be R is equal to C K into brackets C, because there's no coefficient, you own this thing by this. Now, if this is your rate law, then that means this is the rate constant we are talking about. This is the rate constant. So now, if you want this alone will be K is equal to your rate R all over your rate constant. So let's say we didn't assign any question to this. So let's say this is A via M, maybe N. So this will be M. And that is it. So this, the D, the K is the rate constant of the rate, what do you call it? The rate law or the rate equation, which is the proportionality constant. Proportionality constant. I hope you are getting, I hope you get it.
Yes, sir.
Now, they can ask what is meant by the term effective collision. I spoke about this when I was talking about the collision theory. What is meant by effective collision? What is meant by effective collision? Now, I told you that when collision occurs, there's a fraction of the collision that enables, that gives energy or that enables a chemical reaction to take place. And so that fraction of the collision that makes it possible is what we call the effective collision. Is what we call the effective collision. Please, do you get it? Hello, please do again. So we are saying that effective collision is the fraction of the total collision by reacting molecules that can produce chemical reactions. So the fraction of the total collision by reacting molecules that can produce what do you call it? Chemical reaction is what you call the effective collision. Now, effective collision is therefore the collision with sufficient energy to overcome the energy barrier. We said it the other time. And sometimes they can ask you, explain why the rate of chemical reaction increases with an increase in temperature. And so this one, so you use what we call the what do you call it? The collision theory that I used to explain with an increment in temperature of the reaction, it increases this thing, what do you call it? The rate of reaction. I explained that the other time because when that happens, it makes the molecules become mobile, and as a result, it increases the collisions per second. And when it increases the collision per second, at the end of the day, we are able to get an effective collision that leads to what do you call it? A chemical reaction and so on and so forth. And so let's do this one. Bromine reacts with propanol in acidic solution. Did we do this the other time? Did we do what I'm reading the other time? Bromine reacts with propanol in acidic solution according to the equation. So, according to the equation, this is the equation CH3 CO CH plus Br2 plus Br2. And this one is a catalyst. There's a catalyst. This is H plus. And that will give you C CH CH2 Br plus now, then the question says that the rate law is found to be the rate law. So let me just type this so we'll make it simple. The rate law. The question still right that the rate law is found to be K bracket propanol in the bracket H plus. This is H plus. So that is the rate law. That's the question. Now the question states that one, what is the overall order of reaction? What is the what is the overall order of reaction? The question states that what is the significance of the absence of the bromine? Significance of the absence of the bromine in the rate equation. So the questions read that the bromine reacts with propanol. This is a propanol, and this is a bromine. It reacts with it in an acidic solution. So this is the acidic solution I'm talking about, according to the equation. Now, so this is the equation. This added to this in an acidic solution, then we get this one. Now, the question then it gives you a further right that the rate law of this. The question gave you this. You realize that an anomalous that if the question didn't give us the rate law, we would have included Br and just look at this as a catalyst. But the question further gave you the rate law to be propanol. This is this propanol is this propanol and this hydrogen. So the question He gave it to you. Then the question asks that what is the overall order of the reaction? Now looking at this, the overall order of the reaction, you realize that this one, this one is just 1, and this one too is just 1. This is 1, this is 1. They are not raised to the powers or something. They are raised to the power 1, 1 each. So the overall order of reaction will be 1 plus 1, which will give us 2. That you already know. Now, then the second question says that what is the significance of the absence of the bromine? What is the significance of the absence of the bromine in this rate equation? Now you realize that the other day when I was teaching the order of reaction, I said that when the concentration of any of the molecules are altered and it affects the rate, then for instance, if I double any of the concentration of the reaction and it also doubles up the rate, then that means keeping the other molecules constant and also doubles as the rate, then that means that one is in order 1. However, if I increase the concentration and it doesn't affect the rate, then that means that one is in order 0. And I said if I do that and it quadruples that of the rate, then that means it's in order 2. I remember I did that the other time. I hope you all remember. Please, do you remember?
Yes, sir.
So this one we can say that the bromine is in order 0 because it wasn't included. Because it wasn't included, because if bromine was included, then that means the bromine was raised to the power 0. If the bromine is raised to the power 0, then that means any number raised to the power 0 is 1. So that means here you won't see it. It has no effect on the rate law. Did we get it?
Yes.
So we can say that the absence of the bromine concentration in the rate equation means that the rate reaction, so it means that the rate reaction is independent of the bromine. And I said it's independent, it's independent on the change in the bromine or the concentration of the bromine. So this means that when you change the concentration of this bromine, it does not affect that of the rate. So the rate, we can therefore say that the rate is independent of the concentration of the bromine. That means it doesn't depend on the the alteration of the concentration of the bromine. So however, we can conclude that the bromine is in order 0. Please, do you get it?
Yes, sir.
Good. Now let's try some more questions so that we get the concepts. Discuss at a certain temperature. And at a certain temperature. Are you writing at a certain temperature? Let me clean that this one. At a certain temperature. At a certain temperature. An alkyl bromide, an alkyl bromide, an alkyl bromide. Alkyl bromide reacts with hydroxide ions in one step as the follows. React with, so alkyl bromide reacts with hydroxide ions in one step. So this is the step. The step is given by RB small r. The R is the alkyl group. When you do organic chemistry, you get it. OH maps to, I'm using equal to, maps to ROH, sorry, ROH. That means alkyl oxide plus Br. Now the question reads that write the rate equation for the reaction and give the units of the rate constant. So we should write, the question says that we should write the rate equation, we should write the rate equation of the reaction. Who can help me write the rate equation? I mean, are you done writing? I mean to say, are you done writing a biology this morning? You don't have any paper in the afternoon. Hello, who can help me write the rate law, the rate equation? What will be the rate equation? Who can help me? Oh, talk to me today. Hello.
The R
So R
is equal to
is equal to,
the concentration of OH.
but no, you didn't bring the constant. So K,
K, K the
yeah,
concentration
concentration of
OH.
OH. Okay, OH, and that of RBR. RB is small r.
Yes.
So that is it. So this one will be my rate equation. This will be my rate equation, which is very correct. Now the question says that we should find for the unit of the rate constant. So you are looking for the unit of this rate constant. But before we can be able to get the unit of this rate constant, let's first make the K stand on it to the subject. So K will be equal to, what will it be? It will be equal to it will be equal to R divided by, right, OH R B small r. That is it. Now we want to look for the unit. What R is measured in what? The rate is measured in mole per dm cube
Cube per second.
per dm minus cube per second. And so all of that divided by, let me just put it in a bracket. So all of this divided by, what is the formula for concentration?
Mole per dm.
So formula is mole per dm cube. Mole per dm, let me write it 3. But and this one too is, there are two concentrations. So this one to mole per dm 3. Dm 3. So that is it. Now let's look for the, so the unit is what we are still on. And so what we are going to do is, let me just pick this, now I'll make it. So what we are going to do, we are going to get m mole dm minus 3 s minus 1 all over this mole, and because their concentration don't multiply, so when they multiply, I'm going to get mole squared, right? Mole squared dm minus 6. Please, do you agree?
Yes.
So when we get to this thing, then that means we can bring any of them at the top. Now, so K will be giving us mole negative 1. Mole negative 1. When this one goes to the top, it becomes positive. So it will be positive 3. dm 3 s minus 1. Do you get it?
Yeah, we are done with the biology. So they have to start
Yes,
with
sir.
math. Let's move. That English.
Please, do you get it?
Yes, sir.
Yes, sir.
So that is it. Now, the overall order of the reaction is what? What's the overall order of the reaction? The question says you should find for the overall order of the reaction. What is the overall order of reaction? What was it?
2.
2. So the overall order of reaction is 2. Good girls and boys. Now, the other question says that what will happen to the rate of the reaction when the concentration of the hydroxide ion is tripled? What will happen to the rate of the reaction when the concentration of the order of reaction is tripled? What will happen? What will happen? What will happen? Now, when the order of, what will happen to what will happen to the rate of the reaction when the concentration of the hydroxide, that means when this one is multiplied by 3, what will happen to the K? It will also be multiplied by 3, because 3 raised to the power 1 will give us 3, and so this one to be 3 using more ratios. That is it. I don't know if you get my point. When it is tripled, that means when this is kept constant and we bring 3 here, this one is tripled, then that means this one to be tripled. So it will be still, because we know that the order of reaction is 1. And so when this one is tripled, 3 raised to the power 1 is 3. And using the mole ratio, then you can see that the rate will also be tripled.
Okay.
Do you get it?
Yes, sir.
Now you get to some questions where we'll be doing typical calculations on this, and you get to understand it better. So since the reactants are gases, it increase in pressure increases the number of reactant molecules per volume. This leads to so and so. So when it is tripled, the rate of reaction is also triples. Are you getting it? Now they can also ask you that discuss the effect of increased pressure on the rate of reaction. Discuss the effect of increased pressure on the rate of reaction. So you can use what I gave you the other time, using the effective distance and so on and so forth, the concentration and the rest. You can do that. Now let's do some more examples. We have some ones I want us to look at the experimental ones. That one is a little bit distant. So when I take you through that one, then I know we are done with everything on this one. So let's do this one. Consider the hypothetical reaction. Consider the hypothetical reaction. I think we started this last week, but we couldn't finish. So consider the hypothetical reaction. Consider the hypothetical reaction. Consider the hypothetical reaction. Okay, now x plus y plus z will give you maps to. So don't use equal, please use the maps to. Maps to q plus p. Now you've been given the rate law. The rate law was found to be, this is the rate law you are given. Rate is equal to, in the question, is equal to k x, then you are given y raised to the power 2. Raised to the power 2. Now the first question reads that what is the order of the reaction with respect to each of x, y, and z? So what's the order of reaction? What is the order of reaction of x? What's the order of reaction of x?
1.
1. Correct. What's the order of reaction of y?
2.
Y is 2. What is that of z?
0.
0.
0.
So what will be the overall order of reaction? What will be the overall order of reaction? That's question 2. What will be the overall order of reaction?
3.
3. Good. So that will be 3. Now, the question reads, if the concentrations are expressed in mole per dm cube and the rate is in mole per dm cube per second, deduce the unit for the rate constant. That's what we've already done in the first one, so we won't waste our time. Now, the II says that show how the rate changes if the concentration of y is doubled, while that of x and z remains constant. Show how the rate changes if A, concentration of y is doubled while that of x and z remains constant. So they are saying that if y is doubled, so so let's repeat our rate listing. This is what I was just trying to say. So this is what we are going to get. Sorry, R, we are given to be k into bracket x. So already we know that for z it is 0 order. For z is 0 order. Raise the power 2. Now they said when y is doubled. When y is doubled, so r will be equal to k x. It is doubled, so that will be 2, right? 2 times y.
Yeah.
When y is doubled, that means that will be 2 times y. Still raise the power 2. Now 2 raised to the power 2, what are we getting? So let's name the first one when it is double. Let's name that one R1. So the main, when it was doubled, we name it R1. Before it was doubled, the main distance we name it R. Then we name this one R1. We want to see the change or the ratio between the R and the R1. So K, when 2 is doubled, what are you going to get? 4, right? Yes, so we are going to get 4. So we can bring the 4 out. You can bring the 4 out and still come and get X. That will be Y. What is it? X, Y raised to power 2. Please, do we understand this? So our R1 will become 4K X, Y raised to power 2. Please, are we there? So let's name this one maybe equation, maybe the second equation, equation 2. Equation 2 or something. And this one. Now I want to find the relationship between the rate itself, and when it is doubled, what is the relationship we are going to get? So before we can find a relationship, let's do division of equation 1 by equation 2. So that we are going to get, we are finding the ratio. So R all over R1, so that we can be able to relate. It will give us, what are we getting? It's going to give us, we are going to get Kx into bracket Y raised to power 2 divided by 4K X Y squared. Please, have you seen how it works? Have you seen how it works? Now I want to know the reaction. So you bear with me that when we do it this way, the whole of this will cancel. Do you agree? So I'm going to get R all over R1. Do you agree with the math I'm doing? K, the whole of this will cancel. So we left it 1 all over 4, right? You left it 1 all over 4. Have you seen it?
Yes.
So this will be R all over R1. We are just checking that when it is doubled, what are we going to get? All over 4. So when we are going to get it, then when we want to relate it, we can say that 4, when you cross multiply, we are going to get 4R is equal to R1. Have you seen it?
Yes.
And so, once already we know that the R1 is when it is doubled. And so we are trying to say that when it is doubled, the 4 it's multiplied by, the 4 is also doubled by 4 folds, or it's increased by 4 folds. The rate of the reaction is increased by 4 folds. Do you get the mathematics here? And so that means when R1, the R1 is this. When R1 is doubled, the rate of reaction is increased in 4 folds. Do you get it?
Yes, sir.
Please, those of us who doesn't understand, please let me know. Do you understand the mathematics we are doing? And so we just cross multiply. So this is just a typical ratio. So 4R is to 1R. This means that, but already we know that this R1, we allowed R1 to stand for when it is doubled. And so when you realize that when R1 stands for the rate which has been doubled, or the when Y is doubled, so that is it. So when Y is doubled, the entire rate of reaction is quadrupled. Let me put it that way. It was increases in 4 folds. So as a result, we can say that this one is in order what? Please, this one is in order. Hello, this one is in order. Oh, my me. He said, so this one will be, this is not in order 1, this will be in order 2. Because when this one was doubled, this has increased in 4 folds. So it's in order 2. Do you get the mathematics here?
Yes, sir.
The rest, please, do you get the mathematics here? You know, when this one is doubled, it was just doubled, but here it has increased in 4 folds. So this one is in order 2. When it was to be order 1, then that means here would have been 2. And so here would have been 2. So once this one was doubled, here would have been 2, not 4. So then we see that it is in order 1. So if you have to break this one down, you realize that I'm going to get 2 raised to the power 2. R is also equal to, the order is 2. Oh, please, do we all understand?
Yes, sir.
Now, the question also reads that when x, y are constant and z is doubled, okay, show how the rate changes if the concentration of x is doubled. Sorry, the concentration of z is doubled, while that of x and y remains constant. What are you going to get? Since r does not depend on z, and we know that since z is in a 0 order, then that means r will still remain the same. Even if z is doubled, r will still remain the same because z is in 0, is a 0 order. Are you getting it?
Yes, sir.
Good. Now, okay, let's do some the this thing will end very soon. Immediately ends, then you join again. We are going to do some experimental works on this same issues. Then we are done for the day. Some more experimental works. How when you are given a data and you have to find for the order of reaction, how the calculations are done. Those writing, are you done? How the calculations are done. So we can write the results obtained in the determination of the rate of reaction. The results obtained in the determination of the rate of reaction. You can write it. The results obtained in the determination of the rate of the reaction. Results obtained in the determination of the rate of reaction. Have you written that? Immediately ends, you join again, please. It will end very soon, so I'll continue. Ends, you join again.